good evening. So this group 1 presentation was to discuss, have a discussion about the leucine zipper. So the first part is talking about how the two alpha helices are held together, and that would be regarding leucine and its hydrophobic effects. So there were 7 leucine residues in a row in these alpha helices, and these are hydrophobic. So by having several leucines together in the center of this structure, you would be inducing the hydrophobic effect. So leucine, being a very hydrophobic structure, does not like water. So by coupling all these together, you have a hydrophobic effect in the center of this zipper structure. That was what would be holding the two alpha helices together. One possible residue that could replace leucine would be isoleucine. And I chose isoleucine because it also has a side chain with 4 hydrocarbons, and it's hydrophobic and nonpolar. So by substituting isoleucine for leucine, you would still be experiencing that hydrophobic effect within the core of those leucine zippers. And it would still maintain that strong bond and be held together. One residue that would destabilize the core would be one that is water loving. And a amino acid with a side chain that is hydrophilic, which is water loving, would be serine. Serine is polar, aka hydrophilic. So you would not want to substitute leucine for serine, because you would then see serine basically repelling from the core of that leucine zipper, because it wants to be on the outside where it can interact with water, not on the inside where it's away from water. So that would be one that you would not want to substitute. Next, we want to talk about finding an amino acid pair that would interact in a similar manner to lysine and glutamate. So lysine and glutamate associate together because of their electrostatic interaction, and this means that their positive and negative charges are attracting one another to each other and creating a strong non-covalent bond that also keeps those two alpha helices together. And so that they like each other, just like the hydrophobic effect of the hydrophobic molecules in the hydrophobic core. The positive and negative charge attract each other and they are drawn together. So you would not want an amino acid like aspartate to be interacting with glutamate, because they both have negative charges, which means they would repel each other. So that's not something you want. But if you were to get an amino acid with a side chain that has a positive charge like arginine, and couple that with an amino acid with a side chain that's negative like aspartate, then that would also have electrostatic interactions that would be attracting one another rather than repelling one another. So that would be an ideal amino acid pair whose side chains interact in a similar manner to lysine and glutamate, and could further stabilize that leucine zipper structure. So that's what you want.